Hello everybody, I'm Ahmed Haider and today I'll be introducing you to our work, which is the influence of severe climate conditions on the properties of soil reinforced with waste plastic shreds. First of all, one of the most common challenges faced during the construction of highways is encountering weak clay soil. A common option of improving such soil is the practice of mixing cement into soil. Due to its sizable improvement, it gives the soil properties and also it is a cost-effective way. However, this solution is considered harmful for environment. Also, the most important issue that is usually forgotten, which is the durability of stabilized soil, where the stabilized soil gets subjected to a number of severe weather conditions throughout the seasons of the service years. These conditions may cause the stabilized soil to lose its strength. Durability can be defined as the capability of a material to maintain stability and integrity over large periods of exposure to weathering. So if we summarize the problems within this study, they can be as follows. Whether weak soils can cause serious problems to highways, hence they need stabilization. Cement stabilization is a cost-effective solution, however, it is harmful for environment. There are waste disposal problems all over the world which cause serious environmental problems. So the idea of this test was to combine between these problems, allowing for environmentally friendly solutions, and that is by adding PET shreds to cemented soil as a reinforcing material. And about the aims and objectives of this study, they were first examine the effectiveness of PET shreds to be used as a soil reinforcing material, to study the influence of severe climate conditions on cemented soil reinforced with PET shreds through wet and drying cycles on durability in terms of loss of mass, stiffness through UPV, microstructure through SEM, and mineralogy through XRD, and also to study the effect of porosity binder index on durability and stiffness. If we come to the methodology that was followed to achieve these objectives, it was as follows. First of all, materials were collected. After collecting them, PET shreds were prepared and the materials collected were tested. After testing the materials, two different sizes of PET shreds were selected, which were size number 10 and size number 40. After that, the PET shreds percentage to be added to the soil was selected, which were 0 from 1 at an interval of 0.1%. And after that, CBR samples of soil with and without PET shreds were prepared, and then the CBR samples were prepared to find the optimum PET shreds percentage range to be used in the to reinforce the cemented soil. And after that, three different percentages of cement were selected to be added to the soil, which were 5, 7, and 10. After that, the CBR samples of cemented soil with and without PET shreds were prepared, and then they were cured for 7 and 28 days. And after curing, the samples were tested for durability, stiffness, microstructure, and mineralogy. Here, as you can see, it shows the preparation method of the PET shreds, and also here are the tests that were carried out. If we come to the results, first of all, if we consider the effect of PET shreds addition to CBR of the soil, we can see that by adding PET shreds, regarding the size and the amount added, the CBR was getting improved by adding PET shreds. But size number 10 proved to be more effective in improving the CBR of the soil, and also the optimum percentage of PET shreds was found to be 0.6, 0.7, and 0.8. Also, if we consider the effect of adding PET shreds to cemented soil on durability, we can see that by adding PET shreds, the durability of the cemented soil was being improved as the loss of mass was being reduced. But size number 10 was better in improving the durability of the cemented soil, and also by adding a higher cement content, the durability was getting improved more and more. Also, if we consider the effect of adding PT shreds to cemented soil on stiffness, we can see that in regarding the 7 days of curation, we can see that the shear modulus in the initial cycles got reduced, and then in later cycles it got increased up to the 12th cycle. But in the case of 28 days, as you can see, it kept reducing, like the stiffness was getting reducing and reducing from the first cycle up to 12th cycle. However, the loss of stiffness was getting improved. It was reduced by adding PET shreds, which is a good thing, yeah. Also, another important thing which was studied is that the impact of adjusted porosity binder index on loss of mass, where a relationship was found between this index and the loss of mass, and a high coefficient of determination was gotten. Also, the same story for stiffness, yeah, which is the maximum shear modulus. Also, if we come to the relationships among shear modulus and loss of mass, we can see that there is a relationship between them, and a high coefficient of determination was gotten. And as you can see, as the shear modulus increases, also the loss of mass decreases too. Also, if you consider the effect of wetting drying cycles on mineralogy through XRD, we can see that the main two peaks were quartz and calcite, and these peaks were getting increased by subjecting the samples to more cycles. But these peaks were higher in the case of samples containing PET shreds of size number 10. Also, if we consider the effect of wetting drying cycles on microstructure through SEM, we can see that like the intensity and the size of the cracks and voids was getting increased by subjecting samples to more wetting drying cycles. However, if we consider samples with PT shreds size number 10, we can see that the intensity and the size of the cracks and voids was much lower than in the case of the samples with PT shreds size number 40. Yeah. So if we come to the conclusion, we can see that the PET shreds addition to the soil improved the CBR up to about 90% of plain soil, but and size number 10 was better in improving the CBR of the soil than size number 40. And also the optimum percentage of the used ones was to be 0.6, 0.7, and 0.8. Also, the addition of the PET shreds to cemented soil improved the durability compared to soil stabilized with only cement, and also size number 10 was better than size number 40. Also, the PET shreds inclusion reduced the stiffness loss through wetting drying cycles. Also, the usage of porosity binder index for representing the performance of the mixes studied in this study was valid, and also the trial to correlate between loss of mass and maximum shear modulus was proven to be valid. And also, according to the XRD, the main peaks in the mixes were quartz and calcite, and these peaks were getting increased by subjecting samples to more wetting drying cycles, and also the cracks and voids initiation increased by subjecting the soil samples to more wetting drying cycles, and that was of course due to the severe conditions. And thank you for listening.